He has always been passionate about finding simple, scalable solutions for hyper-complex challenges in manufacturing. The title of his today's talk is Disrupt Without Disruption. So, let's welcome Mr. Rajat Srivastava for his talk.
Hello everyone, hi, I'm Rajat, the same person who was introduced. When my marketing team told me that I have to come here in this campus and deliver a keynote, it was a bit surprise for me because we working in a manufacturing industry, I was like, what I'm going to do with students. It has, me coming here was problematic at two levels. A, I'm one of those people who has spent more time out of the classes than within the classes. And B, again, we are looking for manufacturing folks. So then my marketing team told me that you know how to find solution of things, and this is what you boast about yourself. So we are fairly confident that you'll be figure out something what you can do with the session. So here I am, and in last couple of days since I've been given this mandate, I've been trying to think what we can talk today, right? What we can discuss, which is something which is a little informative for you, as well as we as a company, when we are coming here, we would also be able to get some ROI out of it, ROI out of this entire time investment, right? So we thought, how about we share some ideas which eventually we can work on together, right? Eventually, okay. So for last decade, we have been knowing a very interesting insight, right, which we have not made public yet to the outer world, right? And this secret is something that we have been able to figure out a wormhole which allows us to go back in a time where there is no Facebook, no Amazon, no Blinkit, no Tesla, no ChatGPT, right? So I thought if I can take you guys to that point of time, right? And you being computer science grads and masters and researchers, I thought there cannot be a better value proposition for the time that we are investing together in this session, right? So I thought if I can let you in this particular secret, you guys will be able to make a lot out of this fact, okay? So the thing is, what is this fact, okay? And so in order to tell you this, I have to take you a little back in time, and I'll tell you how I got to know about this fact, how I got to know about this access which allows me to go in a time which has not been exposed to the Facebook and the Teslas and the GPT of the world yet, okay? So this entire thing starts back, somewhere a decade back when I was right out of college. I started my career with the very renowned two-wheeler automobile company. I worked there merely for a week, and then I resigned from there because I wanted to do something in designing. So then I joined a small-time design company, and I worked there, and I happened to do a decent enough job that within a year they made me their managing director, right? And while working as a managing director, I was doing this very particular thing with factories, where we used to go to factories And in every factory, they have they happen to make a thing called Kaizen, right? Kaizen is a Japanese word, which loosely translate to making tools which simplifies your activities, simplifying your job, right? In factories, obviously, they are doing a ton of job, so they have to make a ton of Kaizen, right? But while Kaizen is a very scientific term which has to be done through engineering, through design and all these things, in India we happen to do it in a makeshift arrangement, or the way we have translated Kaizen in India is Jugaad, right? Which is just hit and trial. So whenever there is a challenge, we sort of do the hit and trial and then we make the tool, okay? So I realized there is an opportunity there. And the company that I started working as an intern was a design company called CAD Arena. They used to train students to do designing, 3D designing and simulation and all right? So I realized that, well, every single training institute in the country is just stick to one particular book, and to every single student they were giving this one book, and they were transcribing all these designs through that student, and then that student was supposed to be a designer, which I realized that is a bit faulty approach, right? So and having this gap identified in the industry of Kaizen, I thought, what if we can bridge the two, okay? So I started going to factories and started saying that you must have a lot of Kaizens, you must have a lot of makeshift arrangement. What if we can do the engineering for you, right? And when I'm saying what if we can do the engineering for you means, if we can take your tools, we can do the reverse engineering, we can take the dimension, we can make 3D models, we can perform simulation, we can make a prediction out of that, okay? They said, why not? And on the top of everything, I offered it to do it for free, right? So definitely I got traction, a lot of traction, okay? So, and that's how I started my career with CAD Arena, and I ended up becoming managing director of that company. So while doing this activity, we expanded that company from merely 3 centers to like 20 centers. We had collaboration with more than 50 to 60 colleges, including IIT Roorkee, IIT Delhi, right? And during one such project, right, I got an invitation from Bajaj Auto, right? And in Bajaj Auto, they had a very similar requirement where they had some Kaizens and they wanted to do a reverse engineering, and they wanted to produce the documentation for it and all that thing. I got invited, right? And the person who invited me was no one but now my co-founder, and then my real elder brother, Nishant. Just because we have like 4 years of age gap, and we know how 2 brothers with an age gap of 4 years, how well connected they are, right? So we were also like barely connected at that point of time. So in fact, one of his friend recommended that your brother does the same, why don't you call him to do this Kaizen conversion kind of job, right? So he invited me, I went there. Well, everyone was saying that this job can be done in 3 to 4 weeks. I did that job in 2 to 3 days, and then when we were done, I was done impressing him, being a younger one, right? So when I earned my respect through him, we were sort of partying a little bit, and we were decently intoxicated when Nishant told me about this interesting wormhole, right? So he mentioned this very interesting insight that despite what we see in those discovery documentary about factory, about how these factories are supposedly working as in a state of the art kind of fashion, where everything is super high tech, everything is running out of technology, everyone is super proud of working in these environments. Contrary to that, how factories are getting operated in the most traditional way possible that we can imagine, right? If you guys can truly imagine, back in 2000 or 1990s, the max that we were getting in terms of digital banking was getting our account balance as an SMS on our Symbian phones, right? That was the height of digitization back then. Manufacturing is still in that phase only, right? The maximum information that they get in real time is few very limited numbers in terms of messages, right? So why exactly the thing is like that? So every factory operate out of numerous set of processes, okay? In a typical factory, there are departments from production, quality, safety, maintenance, utility and store, right? And across all these departments, they are conducting about 200 to 300 processes, right? Well, now you might be wondering what is a process, right? Let me give you one simple example of a process, rather two example. One process at a scale, right? So we all must have used Zomato, right? We all. I saw the advertisement here, so you guys must be having Zomato here, right? So in Zomato what we do, whenever you wish to make an order, you have an environment where you can see the available menu, right? And then you can click on an item, you can add the quantity, you can add your address, right? And then you make the payment and the order is processed, right? And then you can track if the rider has reached to the restaurant, if the rider has picked up your order, and if the rider has entered your society gate, and if the rider is at your gate, right? This is a process, right? Every time when you are making order, the same exact steps will repeat, right? This is what defines as a process. When same steps repeat every single time in a definitive fashion, that's a process, right? And you won't believe the world is getting operated out of process, whether it is this college, whether it is maintaining this particular seminar hall, or whether it is running the army. Everything is driven out of process, right? So manufacturing is no different, right? So being such a complex environment where so many activities has to happen, there has to be predefined process, okay? So these are some of the example of these processes, okay? Now the challenge is while in every single factory similar set of processes gets followed, there is no universal definition of these processes, right? I'll take example of a very simple process called breakdown handling system. Breakdown handling system is nothing but a sort of a ticketing handling system, right? Whenever there is a machine which is into a breakdown, you should be able to report it, and when the reporting is done, someone should be able to come, fix, and then we should be able to move on. But in every factory, there might be a different definition. In one factory, they might say whenever the breakdown will be reported, first someone will verify that whether it is actually a breakdown or not, and then someone will come and fix, right? And then someone will approve, and then someone will approve, and then someone will approve. In another factory, there may be entirely different definition, okay? Now, it is due to this particular nature of these processes, almost 98% of the global manufacturing is still in a very primitive stage when we speak about process digitization, right? So there are two aspects of a factory. One is a machine, right? So machines are being upgraded like anything, right? With the enhancement of electronics and all. But these processes, due to their variable nature, they are not being transformed the way they should be, okay? And also, us being developer and us being programmers, right? There is a difference between us and a painter, right? Can anyone take a wild guess, what is the difference in between a programmer and a painter? I hope so. Not, right? So the thing is, as a painter, while both is a job of detailing, right? While both is, in both the job, you have to take care of every single stroke that you are making, right? But as a painter, you would want that my work should be as exclusive as possible, okay? And as a programmer, you would want my output is as scalable as possible, right? So unless we as programmer, we don't find our work to be scalable, we don't get that much interested in taking up that particular job, right? And this is that same thing that happened with manufacturing. Thus, just because there is no global benchmarking, there is no silver bullet which you make one product and that goes to every single factory. That entire market is like fairly open. Okay. To give you a benchmark, like why I said I have this wormhole which takes me back in the time. What I actually meant, the opportunity that we have seen across Facebook, Amazon, Zomato, Blinkit, Tesla, and all these guys, ChatGPT, we have a similar quantum of opportunity available in the manufacturing as well, right? So just to give you a comparator, globally there are 10 lakh pin codes, right? 10 lakh pin codes, and every single company that we know today is fighting for their revenue share across all these pin codes, right? And so many of them can't even go to all the pin codes, right, due to their geopolitical issues, right? At the same time, globally there are close to 10 lakh factories which is doing 100 CR plus revenue, right? While in one segment in the 10 lakh pin code area, there is this abundance of company, right? Everything that we know today is there. While this 10 lakh, across 10 lakh factories, the market is totally white. It's absolute white space. Okay, it's that big of an opportunity. I just wanted to make sure of it. Okay. So what is possible? What exactly we as a company we are trying to achieve, right? First, we have dedicated last 10 years of our life just to perfect a platform that we know as DFOS today, Digital Factory Operating System. It's a no-code platform which can seamlessly transform processes of any factory. Okay. So earlier, what used to take about 6 to 8 months to make a manufacturing application, right, business application, now it takes less than 4 hours to make it on DFOS. That is the efficiency that we have been able to achieve over a decade. Okay. Second is, obviously, just because we are working for the manufacturing sector, we have made sure that whatever product that we have made, it should be able to talk to everything in the ecosystem. Like in our personal life, Zomato, when we use Zomato, right? When the update comes, it also comes on my watch. It also comes on my phone. It also, I also get a ping on my earphone, right? So the entire ecosystem is connected, right? Similar in manufacturing too, when you are working across different technology from IoT to ERP to various computer vision and all that thing, right? We have to make sure that our technology is talking to everything, right? So we have sort of achieved and perfected it. And as a significance of that perfection, all the logos that you're looking at right now, these are our customers. So currently we are active across more than 600 plus factories. We are there in more than 250 plus logos. But the highlight of all these things is we never had a sales team so far, right? Because we realized that the problem statement is so complex that unless we actually crack it, there is no point of building a muscle of sales, right? So though we never built that muscle of sales, but due to our product market fit, we have been able to onboard all these logos and customers. In fact, Unilever is using DFOS right now across all the factories across Southeast Asia. Dabur is using across all the factories globally. Nestle is using it across all the factories pan-India, right? And same goes for everything. In fact, for Hero MotoCorp, we have just onboarded more than 350 plus of their supply chain. So everyone is connected now. Okay. So this is the first thing that we have been able to achieve, right? Now that digitization bit is completed, okay, we are all set to go to the next stage of our journey where we want to make things more efficient, right? Right now we have made things accessible, okay. So right now, before DFOS, how things were happening, everything was largely paper and Excel based. Nothing was accessible, and it is one hell of a nightmare, to access any set of data. After DFOS, first we have solved this. Okay. Now post solving this, so now we are capturing a lot of data. Okay. So the next activity is to bring the efficiency to this manufacturing world, and that's where we require computer scientists like you guys. Okay, and that's why I'm here today largely, and there is a huge ton of opportunity, of building stuff over the data that we are capturing. Okay, here I'll take a very quick pause, and I'll again draw a parallel in between us and Facebook. Right. So one thing that I fundamentally believe, that what Facebook has largely done, right? Maybe it's a social networking platform. It connects people and all that thing. But beyond all those marketing stuff, what they have fundamentally done is that they have made the survey process real time. Okay, before Facebook, in order to get the feedback of any product, either you have to get a focus survey, right, to know if the customers are liking it, if they want this or that, and all that thing, right? In most of the cases, most of the marketing effort was not getting held back as well, right? So let's say if you have put a giant holding in some prime location of some area, right, you never get to know how many people actually glanced at it, right? That is a gap. Okay, Facebook made it all real time, and once all that abundance of data is there, now it's up to you to make everything from Cambridge Analytica to Amazon, right? It's totally our call, like how we want to leverage that data. Okay, a similar thing, in fact, during the break we were discussing a couple of ideas. For example, one of the thing is, again, for the breakdown process only, right? Right now, everyone before DFOS, everyone was reporting breakdown on a paper, and then the closure of the breakdown was done on a paper where they were writing the reasons, and then they were signing it off and all that thing. And that paper was getting filed up in a file, and it was never accessible to anyone, right? From there, we have at least brought it to a stage where the breakdown is getting reported either through IoT or through a mobile phone application, and the closure is getting captured in a digital structure, right? So there are a few, okay, not okay, drop down kind of answers. There are a couple of scans and everything, and then there is a text field, right, where the technician writes his observation. Okay, now that observation is a gold mine. Okay, because it's a human. The entire approach of computer science should be to centralize the human intelligence. Right, it is human intelligence which is the most distributed thing at this moment, right? And that is why which is stopping us to do a lot of things, right? What if we can combine all that intelligence, right? Using DFOS, we are doing the same. So all those human remarks, all those human observation, now for the first time is stored in a database. We can leverage everything from NLP to LLM to make sense of it, right? To make a prediction out of it, to sort of categorize those data set, right? This is just one of the million opportunity that is there in order to improve, right? Beyond these data models, the next thing that we are doing is engaging stuff, right? Engaging stuff means, if you assume factory to be this giant clockwork, okay, obviously factory is a giant clockwork, everything has to happen in a most precise, optimized fashion in order to make the entire thing run. Okay, so this entire giant, a giant clockwork is basically an assembly of several small gears, smaller gear, which are supposed to be engaged with each other, right? And then the efficiency should be brought in, right? Movement of one gear should be moving the other gear. This is how things should happen. Okay, but I'll give you an example of a set of 4 processes, right? And with that I'll be able to explain how the efficiencies are being leaked within the manufacturing environment. Okay, so there is a process called changeover. Okay, changeover is a process is that, let's say in a hero factory, if they are making Splendor 100 plus 100 cc, and now if they are going to make Splendor 105 cc, they have to make certain changes on the line, right? They have to change some jig, fixture, they have to change certain setting and all that thing. This is what they call changeover process, okay? Now once the changeover process is completed, the next immediate process is first piece inspection process, right? First piece inspection process is कि once the changeover is done, then they make one or two item, right, just to make sure that everything is following the necessary standard or not, okay? And so after the changeover, they do first piece inspection, and once the first piece inspection is started, then they do full-fledged production, and once the full-fledged production is started, then they do the final quality, okay? Ideally, how things should happen, as soon as the changeover, as soon as the changeover is completed, immediately the first piece inspection should start, right? Should start. As soon as the first piece inspection is is completed, immediately the full-fledged production should start, and as soon as the full-fledged production is starting, immediately is completing, immediately the final quality should start, okay? Just because these are solely paper-based disconnected processes, so what largely happen कि the moment changeover is completed, the moment changeover is completed, someone calls someone or drop a WhatsApp or SMS or drop an email or do some sort of communication that now the changeover is completed, and now you have to come and perform the first piece inspection, right? You can totally visualize the delay, right? I mean, it is the most obvious thing that, the moment I'll tell someone that now you have to come and perform that first piece inspection, they will take their own sweet time of 5, 10, 20 minutes and they'll come to the line, and then they will do that activity. In isolation, this 10 minutes seems very small, right? But if you imagine 250 processes being executed, and if such delays keeps on happening everywhere, it basically compounds to this sort of loss, right? Where what it loosely translates to is that almost 95% factories globally, whatever is their design capacity, they're only producing 50% of it, okay? It is this severe, okay? So it is bringing the value proposition of the factory down, right? But let's say if you are not capitalist, you don't want to make more money for your customer, and you are more of a socialist person, right? You want to make the world a better place, okay? Even for that reason, you should be working for manufacturing. Why you should be doing it? Because manufacturing is standalone. Within India, they consume almost 40% of generated energy, right? Almost all the energy that India consumes, 40% of it is getting consumed by manufacturing alone, right? And if manufacturing is only operating at a 50% efficiency, you're getting my point, right? 50% of that energy can be saved, right? If the industry can be slightly improvised, right? So this is that potential. This is both the aspect. Whether you want to make more money, whether you want to make the world a better place, you have both the motivation with manufacturing, okay? So basically, this is the second thing that we do, is to engage processes in between each other, so that these leakages and everything can be eliminated and can be saved, okay? Okay, so I think I've shared the wrong slide. Okay, no worries. Okay. So now, I'll open the platform for folks like you. I would want to understand, what are the, some of top of your mind, things that you want to understand about manufacturing or application of computer science in manufacturing, because about time when we take our learnings and understanding, right, and we leverage to make products of our own, right? As a company, DesignX, what we can help or we can offer in this entire thing is, we offer two things. One is, if you make any product for manufacturing, will make sure that you get the distribution, right? We have the biggest distribution available for manufacturing as we speak today, right? There is no other platform in the, not just in India, but globally, who is spread across all these many factories. So for DFOS, what we say ki it's a distribution channel. So we are collecting a lot of data. Using that data, if you want to make some model, if you have some your own model like computer vision, predictive, and ML, and all this case, all these things, you can just take it on DFOS and deliver it to our customer. That's option number one. Second is we are a research first company, so we always welcome researchers to come and work with us on industrial data. We are collecting buttload of industrial data which we can make accessible to you guys, obviously with a lot of consent and everything to our customers. Yeah. So that was my time, guys. If there is anything specific around manufacturing, anything specific around different technology which is possible around manufacturing. Another thing is, if let's say if you are working or researching onto something which you want to understand how it can be leveraged within manufacturing environment, I can open the floor for those sort of questions, and I'll be happy to answer if there are any. Yes. Yeah.
Suppose there is a factory which is say manufacturing say plan. So what exact things like your software is or your product is monitoring? Does it like just warns off if there's something the supply chain is going wrong? So what exactly are you monitoring in that? Or it is the end-to-end process starting from the HR, like the human connections and the entire process. So what's exactly that?
Okay. So basically every product in a factory takes a very particular journey of raw material to finished good, right? So let me give you a very quick walkthrough of the factory, okay, and it will be helpful for everyone. Now every factory first of all gets some sort of projection from the market, right? Ki this is this season, or this thing is in trend, or our distributors are saying that there is going to be this sort of demand for this particular product, okay? So they give this, they do this demand generation, and then they give a target to the factory, okay? According to that demand, the factory orders the raw material from various supply chain, okay? First of all, what has to be monitored that, whatever raw material that they have ordered, if everything is in time or not, right? That's where we have connected this one automobile company and his entire supply chain, just to monitor that bit, right? If everything is in track or not, okay? Now, once the raw material is at the factory gate, the first thing that they do is to incoming material inspection, right? They perform a material quality check. They check almost 100, 200 parameters, and then they involve the material, right? Then they take it to the warehouse, and there is also a process for it. They take it to a warehouse and they store it to a particular area, okay? Then on the shop floor where the actual manufacturing happens, they as per the plan, they make a production order, and corresponding to a production order, they order the raw material, right? And then that requirement go to the warehouse. Within the warehouse, they have to take the material from those specific areas. They also have to make FIFO, first in, first out, right? So whatever come first has to go out first, okay? So they have to take those materials, they have to take it to the shop floor, they have to either assemble it, process it, convert it to the final product, and there are like at least 50 to 70 steps in between, okay? And then they finally get stored to the storage area, right? In between, on this line, there are safety processes that the machines are safe to work or not. There are maintenance process that machine is healthy to produce or not, right? There are several quality checks, right? Whether the material is following the desired quality or not. There are various parameter control of manufacturing. All those things are in place or not. We monitor everything, all of these things. Okay. So yeah. Anything else? Super.